I was inspired by a couple of papers that I read. Repeatable reverse engineering for the greater good with Panda. This is a cool paper. Yeah, if you'd like to read this, I think it would open your eyes to some stuff. Basically, the technique they use is they run things inside of a virtual machine. Run code inside of a virtual machine. And by virtual machine, I don't mean like Java virtual machine. I mean it's like a virtualization. It's more like VMware.
Okay.
Where it virtualizes the real machine. So what that means is it takes an executable file, not even just the executable file, but like the whole operating system itself. First of all, like if you have Linux or something or Windows, it doesn't matter. It takes the whole operating system and runs it inside a sandbox, and it simulates the CPU that would be executing that code, but that's simulated in software instead of running directly in hardware.
Why do they need to do that?
I mean, in the case of like in general, the reason why people do that, well, there's multiple reasons, but at the very beginning, it was just like, hey, I have a Mac, and it would be nice if I could run Linux also. So then, or I have like a Windows that's running on my computer as well, because some of the time I might want to do some work in Linux. At the beginning, that's why. So people would just install VMware, or VirtualBox is another popular one. And then people can have both operating systems, or all three operating systems, maybe. But another good reason to do it is, this might be another good reason to do it. Let's talk about Docker is a second. Let's talk about the Docker use case. But even before Docker, people were using it to scale out servers, like or like you can just, if you have a same setup for how you want to configure your machine, then you can sort of snapshot it and very easily spawn new machines with that exact same configuration. So I guess people use that to scale out a server farm that has a lot of servers running the same REST endpoint or something like that. So if they need to handle more load because they have more users, they can just spin up more servers like that. Another reason is like if you're a hosting company like AWS, then it's, if you just, instead of letting people share the same server by assigning different people different usernames into the same server, and making sure they are playing nice with each other, nobody is using too much of the computer at any one point. You just give each person a virtual server, and then they can install whatever software they want without bothering anybody else.
Gotcha. So would this multiple virtual server run in the actual same like hardware? Is that how it works?
Yeah, I don't know the details because I haven't built any something like this before, but I imagine it's a mix between virtualizing and running this instructions on the actual hardware, because if you simulated everything in software, it's going to be much slower.
Right.
If you simulate it to CPU. So I think to get better performance, you probably want to at some point throw the code onto the actual CPU, or maybe even on the fly translate some of the code into a form that you want to be able to throw it onto the actual CPU. But I don't know. I haven't built something like this before, or I haven't read enough into it. But in any case, the people who wrote this paper, Brandon, Josh, and Patrick, and Tim and Ryan. These people, they came up with a way of reverse engineering. Like one good use case for reverse engineering is security breaches. So there are hackers that are trying to hack a server, and
Okay.
the way they do it very often is they install a program into your server.
Okay.
Maybe somehow they got access to your computer, and then they downloaded a program that they wrote into your computer, and they got that program to execute in your computer.
Okay.
And who knows what that program is going to do.
Okay.
Well, that's the purpose of reverse engineering, is to figure out what that program did. Right?
Oh, okay.
And so the way, and there's more than one way. This is not the only way to do it, but the way that these guys did it is they just grab that binary, and or they even actually they suggest that if you run a server, you should run it in a virtualized environment like this. And then that way, when there's hackers that are hacking into your computer, they're just hacking your virtualized environment, which you have more control over what the extent of the damage that the hacker can do. And then second, you can actually, because the system that they built, they basically is able to intercept every instruction that happens inside the virtual environment and be able to do some analysis on what actually happened. They can trace, like for example, if your hacker's program read the system password file to try to steal people's passwords, or you can actually track that happening, because in order to do that, they would have to make a system call to read that password file. Right. And
question: is that related to like how RR works, like to check the system call and then to figure out
yes,
what the code did, something like that?
yeah, it is related, and which is why I'm reading the paper. Like I did a while ago, I did like this traversal of papers, and this is one of the papers that was referenced by that cloud of papers. But yes, that's kind of the way RR works is it sort of tracks all the system calls that the executable has issued, and then later on in the replay phase, it'll play them back. So RR draws techniques from this paper, basically.
Okay.
Or other, or the techniques used in this paper, maybe I should say, which is you can actually replay what that attack program did, and but as while you're replaying, so like it's kind of hard to catch it in the act, because in order to do this kind of analysis, it takes a lot of time to do. So it'll slow down everything by a lot if you try to do it online. So what you do is you do like what RR did. You capture enough information so that you can replay everything later. And then while you're replaying everything, you do the analysis right at that point while you're replaying. And that's going to be much slower, but that's okay. You're doing that offline.
Okay.
Yeah. But anyway, I'm talking too much. But you can read this paper. I'm not going to give it all away. It's pretty amazing stuff. But that's part of the thing that inspired me to learn a little bit about reverse engineering. And so I'll show you one of the articles that I found. Let me grab that article. I think the name was something Rick Harris, I believe. Yes. Yep. Yeah. Was a good article. The best part about it is it linked to some example challenges for me to hack. So yeah. So apparently, like this person, I guess, went to the Hobarton School, which is like a coding boot camp, I believe.
Okay.
But basically, I cloned this repo called "Don't Hate the Hacker, Hate the Code," and there's 3 programs that you're gonna try to hack.
What do
So
you mean by hack a program? Like, what does that mean exactly?
I'll show you.
Okay.
Yeah. So this one is like okay. This is not a real program. Obviously, it's just fabricated for the purpose of the exercise. But you can imagine if this was a real program, then it's like asking you for a password and you don't know what it is. You try to give a random one, it says wrong password. So how can I figure out what the password is? There's multiple ways, but there's multiple tools. And if you want to know more, you can read this article. He talks about a few different tools. I'm just gonna show one of them because of I don't want to spend too much time. We have a limited amount of time. I'm gonna show you GDB, which is the tool that C developers, C developer use to debug their program. But you can use it even when you don't have access to the original source code. That's the point. Because GDB can also be used to debug assembly code.
Okay.
So I'll use GDB to do. Oh, I also use RR with this, by the way.
Okay.
Okay, I'm not gonna use RR for now. I might. Well, I might. RR allows me to go back in time, which is very helpful. So anyway, for now I'm not. I might in the next try. So if I do GDB, I need to break. I want to be able to break on the first line of the program.
Okay.
And luckily, let me see. I did info file. That shows me some info about this file. Wait a minute. That didn't really tell me anything useful. But it told me the entry point. It told me the entry point, which that's the first line of the program. But that's not like I could set a breakpoint there.
So you are trying to dig into the assembly.
Yeah.
Okay.
I'm trying to dig into the, and if I'm here, I can say disassemble, except there's no frame selected. I think I can say, I want to print the 10 instructions starting at the program counter register. I need to run the program first. That's why. Okay. I forgot to start the program, which is done with the run command. R for short. Oh, everything has a shorthand. So run, R is short for run. So now I can disassemble. And this is the assembly code. This is the assembly code. And these numbers on the left here. They are the memory location where these instructions is in memory. And you can think of these almost like line numbers. So if you want to set a breakpoint, on this line, then you can copy this line number And you can say, I want to break there. Oh, you have to put a star before. So I'm going to paste that memory address, and that's like, I want to break at that line. And then now I can continue, and it'll pause at that line that I just set a breakpoint into.
Okay. So now you basically have the original code, but just in assembly format.
Yep. It's exactly. It's like you can compare it to trying to debug some JavaScript that's minified.
Oh yeah, I have to do that recently very often.
Yeah. Yeah, it's kind of like that. But in this case, I actually know there's a main function. So as a shortcut, I'm actually gonna set a breakpoint in the main function, and then I'm gonna continue. And now I'm in the main function, and I can disassemble the code in the main function. And then this is basically the source code in the main function.
Okay. So how do you figure out which line has to do with the password?
Yeah. So like you could read this code, and in this case, there's some jump statements. There's some compare and jump statements, and that's usually where they're checking something. So they're calling this checksum function. So that's kind of a clue here.
Okay.
They might be calculating a checksum based on the password. So you can drill down into the checksum function to figure out how the checksum function works. And then here, after they call the checksum function, they're doing a comparison here. So presumably they're comparing the result of the checksum with something, and that something is a hard-coded number, because this is actually this is $, means it's a literal, it's a hard-coded value, and the literal for that value, like this is a hex number. DEE, that's a hex number.
Okay.
I'm gonna use my Mac calculator.
Okay.
If you didn't know, this is extremely handy if you're doing anything like you're trying to hack something.
Okay.
So in the Mac calculator, there's the basic, which is what you usually see.
Okay.
But then there's the scientific. But
okay.
I'm not a scientist, I'm a programmer. So you choose programmer. So, so you use the programmer calculator, and it knows all about hexadecimal numbers. So this is saying I'm in the hexadecimal mode, the base 16. So I'm gonna put in DEE in here. I could paste it, or I could just type DEE, and I can click on 10 to convert it into decimal mode. So I know that, oh, this literal number here is 3,566. I wonder why they're comparing it to that.
Okay, yeah, right. How do you know why they're comparing to that?
That might be a magic number. So what I'm gonna do is I'm gonna pause on this line here. I'm gonna set a breakpoint here. Move this a little up. Okay. Okay, so I'm paused on this line, and at this point, I can actually look at the register, the value it's comparing to.
Okay.
The way I do that is using the X command. X means examine, and it actually examines a memory location.
Okay.
And RBP is a register that contains some memory address. Okay. And here, but here we're going to do an offset. We're subtracting 8 from RBP. So I'm gonna do the same thing here. And so this basically says examine the value of the location at RBP minus 8.
Okay. All right.
And it's 0 for some reason.
What?
Should it be 0? Okay.
So does that mean RBP is 8?
Oh, but apparently it hits that again. Oh, it hits that again.
Oh, what?
So I did continue, and then it stopped on this same line, the compare line again.
Okay.
And then it hit it twice actually. Okay, and it
Okay.
gave me the value of 214. It gave me the value of 214, which is not equal to 3,566. So maybe if I can get this number to be 3,566, then I can crack it, right?
Okay, right. But
So,
how do you?
so but maybe it has something to do with the password that I give to it. Because I put in hello.
Okay.
I put in hello, it gave me 214.
Oh, so you want to put in a different one and test out what number it would
Yeah, I'll put in monkey this time. And then I will let me look at how many breakpoints I have. So info break. I'm gonna remove the breakpoints that I don't need because I only care about this 6001
Okay.
because that is the one that's doing the comparison. I'm most interested in that one. I'm gonna get rid of the other ones so I can say delete 1, delete 2, delete 3, and I'm gonna go. Okay, I'm paused there, and I'm gonna print out the value inside that register. By the way, this memory location here,
Uh-huh.
that's basically a variable in a
Oh,
C program, very likely.
okay. Oh.
It's 293 this time. So it's a different number when I put in monkey
Okay.
versus when.
Why there is 0 again? So what does that 0 mean?
Oh, I think 0 means when I accidentally hit enter twice, and then when I hit enter the second time, it just went continue again, I think.
Okay.
Oh no, I'm sorry. It just did the same previous command again. Oh, but
Okay.
I don't know why. Oh, but it did move. Oh wait, interesting. I think it might have. I think what I did probably actually subtracted 8 from the RBP. That's probably why.
What?
I didn't mean to do that.
So you think you modify the
Yeah,
value right now?
I think I modified the register. Yeah, I did. I did, but okay. I'm gonna in the future. I'm not gonna do that. I need to find a way to show the number without actually modifying it.
Okay.
But anyway, but okay. So what now? I'm like okay. So depending on what password I pass in, I can actually change the number, and we want the number to be the big number like this.
So how are you gonna?
I'm gonna just put a lot of Z's in here
Oh.
and try to get the number to. Oh, still wrong path. Oh wait, I missed it. Let me just try again. Oh, I already broke there. So I'm gonna look at. And now it's B70, and B70. We're getting close.
Okay.
I think as soon as we get to the same number as DEE, then it's gonna work.
Okay.
So let's see, how far are we? No, I'll just put more Z's under it. CDE. We're getting close to DEE, right?
Okay.
Okay, one more Z. Okay. What's DEE minus? So wait. DEE is 3566. So all we have to do is get all of them to add up, and if we hit that number, then it'll work. Actually, yeah, let's just stop here.
Okay.
We don't have to go through the whole exercise, but
I get the point.
yeah, you get the point. So once we hit that number, it'll unlock the thing and it'll work. And yeah, I guess so. What? And there's a couple of exercises that are a little bit harder than this one.
Okay.
I guess what's the point of this? The point is the point is like I kind of was interested in this like I learned a little bit about assembly programming because of the compiler stuff, and yeah, just learning more about how GDB works, like the fact that you can look at memory locations, the different ways of, or the fact that it can disassemble assembly language and be able to walk the assembly language instructions step by step, so that you can debug things even if you don't have the source code. That's pretty interesting to me. And there's actually like a lot of people that do this, like in particular security researchers do this kind of thing. They're trying to figure out how a virus or a worm works by executing the code and stepping through it. There's also people in the video game industry, or maybe not, like the people who are really into games. They like to make modifications to the game.
Okay.
And this is how they do it. They like,
oh wow.
Yeah, they walk through the game line by line, or they look for stuff in, like there's tools that you can use to look at this binary file that is the program. Look into it, and you can identify it. Hey, that's an image right in there. And then if you know that that part of the file is an image, you can swap in your own image, and then you would change the game, right?
Yeah, just change the numbers, and then you can.
Yeah, you can use the text editor to change the numbers, and then you can. So yeah, this stuff is pretty interesting to me, and because it's also very related to what we're trying to do with the debugger, which is debugging is actually reverse engineering something, if you think about it.
Yeah, that's true.
Like you don't know how the thing works, you're trying to figure it out. So the fact that there's people building tools to make reverse engineering easier, that's very close to what a debugger is.
Yeah, that's true.
Yeah. Okay. That's a good stopping point there, I think. Do you have any other thoughts?
Maybe you can send me the paper so that I can.
Yeah, I'll send you this paper.
Okay.
This one. Yeah, the panda one. Yeah,
Right.
it's extremely, it's really incredible paper. Yeah. And then yeah, if you read this, there's another one that's even more incredible. So maybe we'll save that for later. All right, I'll talk to you later then.
All right, talk to you later. Bye.
Bye.